Hello everyone, welcome to Roots of Unity. I am Marzukh, back with another topic. Today, we're going to explore circular measure. Okay, so let's go draw a circle and draw the center, and these are the two radii. Let's say this is 90 degrees. Okay, so how do we calculate the circumference of the circle? It's using this formula, right? Circumference is equal to 2 pi r. The length of circumference is equal to 2 pi r. However, what if we simply wanted the length of this minor arc, this part? The length, the arc, which is denoted, the length which denoted by S. Then rather than being concerned with all 360 degrees of the circle, we should rather focus on this sector only. So how do we do that? Well, clearly we can see that this is 1/4 of the entire circle. We know that it's 1/4 because we divided 90 by 360 degree. This is 90 degree and the entire part of the circle is 360 degree. So this portion occupies 90 degree from the center of the entire circle. Okay, it's quite natural that this arc will also be 1/4 of the entire circumference, since this sector is also 1/4 of the entire circle. So we can write it as 1/4 into 2 pi, or more specifically, we can write like this. Okay. So whatever the angle is for this sector, be it 90 degree here, or whatever any other angle, whether it's 60 degrees, 40 degrees, we can always find the length of the arc using this formula. S is equals to theta by 360 degree into 2 pi r, theta being the angle here, theta. So here theta is 90 degrees, but in other cases it might be something else. Okay, this theta by 360 degree part determines which part of the circle we're concerned with. Okay, so we have calculated all maths related to angles with degrees. Degree is a unit for measuring angles. Today, we're going to introduce you to a new angle measuring unit called the radian. Okay, so we know that the entire circle, one complete revolution here, it's composed of 360 degrees, right? That's how the degree is defined. 1 radian is basically defined as the angle here subtended at the center by an arc that is equal in length to the radius. So this radius, this arc is equal in length to the radius. If this is the case, then the angle here is 1 radian. So what if the arc is twice in length to the radius? Then quite naturally, the angle here will also be twice. So this is twice the length of before. So this angle, it will be twice theta. Okay, so the formula for this is basically theta is equals to the arc length. This is the arc length, and theta equals to arc length divided by radius. This is the radius. So this is the arc length, and this is the radius. So rather than this, we often write it as this form. S is equals to r theta. Okay, so the general formula for calculating radian is this formula, but we usually express it in this way. Okay, so we know the full circumference can be written as 2 pi r, right? 2 pi r. So what if we place it in the formula here? So this here, we placed it in this arc because circumference is basically an arc for the entire of the circle, right? So we place 2 pi r here and equals to r theta, and then we equate. So the theta value comes 2 pi, which means that in a full circle, the angle subtended at the center, what is it? It's 360 degrees, right? In a full circle. So the angle 2 pi in radian unit is actually 360 in degrees. Thus, 360 degree is equals to 2 pi radian. 1 degree, and using unitary method, we can express 1 degree as 2 pi by 360 radian. Well, for any other theta degree, we can express it in radian form using this formula. This is the degree, the conversion formula from degree to radian, and for the reverse from radian to degree, this is the conversion formula. Okay. All right. So we can find out the length of the arc using this formula, right? Well, what about the area? There's also a formula to calculate the area of the sector if this angle is in radian. By using the formula, A equals to half r square theta. So how does this formula originate? Well, like the arc formula, we also, if the angle is given in degrees, then the area would be theta by 360 degree into pi r square. Pi r square is the area of the full circle, and for this portion, it's this proportion, theta by 360 degree, represents this portion, right? So we simply want this portion's area, and we do it by multiplying this proportion into the full circle's area. And we know that 360 degree in radian form is actually 2 pi. So rather than the degree, if you want to place it in, if you want to calculate, if you want to put the theta value in radian mode, so if you have the radian mode, the theta here expressed in radian, we use this formula, which is theta by 2 pi into pi r square. So this pi and this pi gets cancelled, so it's just half r square theta. Here, this is the original formula. Okay. All right. So this is a table of some formula. Feel free to pause and note it down, or take a screenshot. Okay, so now let's do some math. All right, so this is the diagram given. The angle here is 1.2 radian. The radius of this circle is 3 centimeter. And the question asks us to find out the area of the shaded region as well as the perimeter of the shaded region. All right, let's go with baby steps. First, let's calculate the area. All right, we know that the area of the shaded region is actually the entire triangle's area minus this sector's area, right? Here, triangle OAT minus sector OAB. So what's the area of the triangle? It's half into base into height, right? Well, the base here is OA and the height is AT. The base is the radius 3 centimeter. So now we have to find AT using simple trigonometry. Tan of angle AOT is equals to AT by OA. Here, tan of angle AOT, this tan, so tangent of an angle is equals to the opposite by adjacent, right? This is the adjacent. So AT by OA here. So OA is actually the radius. So if we make AT the subject, this is AT. Let's now find out the area of triangle OAT, which is half into base into height. The base is OA, which is just 3 centimeter, the radius. So half into R into AT, which is R tan theta. So half into 3 into 3, tan 1.2. Okay. Now let's find out the sector's area. We can find out using this formula, right? Half r square theta, we know the theta already, it's 1.2 radian. So let's just plug in the values, half into 3 square into 1.2. All right. So let me just So this value comes 5.4. So the final shaded region's area will be triangle AOT minus, triangle AOT minus sector OAB. So this, we subtract this from this. So if we do that, the value is 6.17 in 3 significant figures. Okay, so that's the shaded region's area. All right, what about the perimeter? Well, the perimeter is basically BT plus AT plus the arc AB. Well, we know AT already, right? And we know that BT is actually just OT minus OB, right? BT equals to OT minus OB, so it's just this part. So we can find out OT using simple trigonometry, which is 3 by cos 1.2 if you use the cosine rule, if you just use cos of 1.2. So we do that and we subtract dB, which is 3, and we multiply this r theta here, which is the arc AB, and we also add plus 80. So we know this, we can calculate this, and we can calculate this as well. So if you add them all up, you'll see that we can find out, we'll find out the perimeter of the shaded region. All right, so that's all for today. We wait, I do not want to ruin that. All right, so that's all for today. We have covered circular measure in this video. Hope to see you in another video series. My name is Marzukh, and this was circular measure. See you later.